In this video, we will see how to create and run an online multiplayer game in microStudio. You can now create a multiplayer game very easily, without anything to set up or install. You can create many kinds of games, like RPGs, action games, strategy games, for 2 players up to hundreds of players. What you are seeing now are a few examples of multiplayer games and apps that were created with microStudio. All these games are public. You can not only play them, you can also access their full source code, clone them, or take inspiration from them. microStudio can run your server on multiple clients directly within the editor. In the second part of this video, we will create the minigame you are seeing here to illustrate the process. Before that, here is a little reminder of what microStudio is. microStudio is a game engine, completely free, online, accessible with a simple web browser. It includes a sprite and map editor. Your program can be run and modified in real time. You can create as a team by inviting your friends on your project. microStudio can export your game to HTML5 or as an app for Windows, Linux, macOS, Android, or iOS via Cordova. You can explore hundreds of existing games and their source code in the community. microStudio is also available as a standalone offline app. microStudio is open source under the MIT license. We will now start creating our minigame. We just need to create a project and to check the option to enable the networking features. Here is our project. I have already created 2 sprites. One will be my own avatar in-game, and the other one will represent the other players. The client uses the usual init, update, draw pattern. For the server, we have 2 new specific entry points called server init and server update. The first step is to create a new server instance, which I am doing here. I am then printing a message that will show up in the server console. Now in server update, I will check for new incoming connections from clients. I can iterate over the list of new connections. For each one of the connections, I will just print the connection ID in the console. On client side, I will create a new server connection and will send the first message to the server. Just the text "Hello." We can directly start testing our game server on client. I am now starting the server and I can see that it is running. I am starting the client and I can see that the server correctly reports a new incoming connection. The one thing I forgot is to process the message sent by the client to the server. For this, I will create this loop in server update where I iterate on the list of messages received by the server. I will just print the content of the message to the console. Now I am restarting the client and we can see that every time I start the client, the server logs the new connection and correctly receives the hello message. Now what we want to create is a simple minigame where I can move my character around and where I can see the other players moving their character too. I will start the server side by creating a few useful functions. SendPlayerStatus accepts a player and a connection as arguments and will just send the current player information to the given client. We can easily send a structured object as a message. The player information we need is its coordinates, x and y, its ID, and I am also adding this property, me, which is a boolean telling whether the player is the same as the client receiving the message. This second function, send to all, will send the status of one player to all the current connections, thus all active players. We will now use these functions from server update. The first thing we have to do is when a new connection is established, we will consider it as a player and assign a set of coordinates to it. For the sake of simplicity, in this demo, we are just attaching the X and Y properties to the object connection itself. Now we can send our player status to all active players in the game. What we need to do also is to send all the currently active players to our new player to ensure it can see them right from the start. When the player will move its character on the screen, it will send a message to inform the server of its new position. We will now prepare the server to receive and process such messages. We can iterate on the server messages. We will receive a pair of coordinates X and Y. We assign them to the connection object, and then we can send the updated player status to all the players on the field. We can now switch to the client. On client side, we can remove sending the hello message and we will instead create a players object, which we will use as a dictionary to store all the players. In the update function, we check if the mouse button is pressed, in which case we send the new X and Y coordinates of our player. We can now process the new messages received from the server. What we receive is a data structure with the player's coordinates, ID, and a boolean telling if the player is me. We first check if we know the player already, in which case we update its coordinates. If it is unknown yet, we create it as a new object. All the game logic is now implemented in our client and server. The remaining step is to draw all this on screen. We first clear the screen. We will then iterate on the known players. We store our current player in a local variable player and we will draw a sprite. The sprite we are drawing depends on whether the player is me or not me. We are thus selecting a different sprite name in each case. The sprite is drawn at coordinates X and Y. We will also draw the player name below the sprite. Well, actually, just its ID. Our game is now ready and we can put all this to the test. We don't even need to restart the server, as everything we do is synchronized in real time. We just restart a new client and I can see my character, and I can also move it with the mouse. I will now reduce this window and we will start more game clients. I can move the player in one client and see that it is correctly moving for the other clients too. I am now displaying this QR code, which allows me to quickly launch the game on my phone. This player 7 is me on my phone and it is correctly connected to the same game. That's it! We have created our online multiplayer minigame. We could now export this game in two parts. The client can be exported on one side as HTML5 or Windows app or other platforms. The server itself can be exported as a standalone Node.js application ready to be installed and run on your own server. Thanks a lot for watching. You can find all the information and links in the description of the video. See you!